All right, so this one's not too bad. We're taking a look at some of the key features of polynomial functions. Here it says, use interval notation to identify areas of the graph that are increasing, decreasing, positive, or negative, and identify any minimums or maximums. So, I got some highlighters. These are my Sharpie highlighters. They're fantastic. So, we're going to identify some of these areas, and I'm going to kind of color code them. And then what we'll do is we'll identify them with interval notation, right? So, I'm going to start with the minimums. I know that's the very last one down here, but here's how I see it. I'm going to use blue here, and what I'm going to consider minimums are low areas, okay? Low areas are spaces that if you imagine that it were raining, that we would collect or pool water up. Now, it's important to note that these two regions here are not what we would refer to as a global minimum. Because this function's end behavior has a down arrow on the right, that means it's going to go down in that direction forever. So there is no real minimum here. But we do have a couple of local minimums. These are areas that would essentially collect some water. Everything on each immediate side of them is a little bit higher. Okay, so we have two minimums. I have a couple of maximums. I'm going to color these green. My conspiracy theorists might call these the grassy knoll. Okay, so these are my maximums. All right. When we talk about positive and negative and increasing and decreasing, we have a sort of a situation here that we need to untangle some definitions in our brain. When I say positive, what I'm referring to is a y coordinate. What I want to know is where is the y positive. And we find that when we are in quadrants 1 or 2. That's these regions here. When I say negative, what I am referring to is the y coordinate. That's quadrants 3 and 4. And you'll see that there are 3 distinct sections there. Increasing and decreasing, you probably are already thinking of in terms of positive and negative, because what increasing means is to have a positive slope, and what decreasing means is to have a negative slope. So I want you to envision a little man here. This is me. I'm currently on a treasure hunt, right? And if you're one of my students, you know exactly what I'm talking about. I'm walking up the hills and down the valley, or down the valleys and up the hills, right? And I walk only from left to right. So to be decreasing means that my little man is going to walk downhill, and to be increasing means he's going to be walking uphill. So in the beginning, he starts by walking down this very long hill until he gets to the bottom, until he gets to this minimum. And he stops for a water break where the water is pooled up, and then he stops decreasing. After a few minutes of rest, he climbs up to the peak of the next hill to get a good view, and he stops increasing at the top of that hill. That's C, that little maximum. He sees some more water. He's rather thirsty, so he heads down the hill when he's decreasing again, grabs one more water break before he has to climb this big one, and then he begins increasing again until the inevitable downfall, and he stumbles and falls down for all time, until infinity. Okay. Speaking of it, it's important to note that all of these points here are great little identifiers, but there's nothing at the ends. We've got to remember that out here at the left we have negative infinity in the x's, and over here we have positive infinity in the x's. Now this does also have an end behavior that is positive infinity on the left and negative infinity on the right, but what we are looking here is the x values when we're talking about where things happen. Okay. Now down here, I want to describe these locations. With interval notation. Okay, so I've got increasing, decreasing, positive, negative, maxes, and mins. So I'm going to color code these. Increasing, those are my purple regions, right? These are my purple regions when I'm increasing. I'm going to use interval notation. Remember, interval notation is kind of like a point. Okay, it looks like a point. So for example, I'm increasing from B to C. So this right here means from B to C. And we're also increasing from D to F. So we combine them. This is a union symbol. Right there means union, or combine it with, okay? So 2 purple sections. All right. Decreasing, those are my orange sections, right? My orange sections. I have 3 of them, right? So I'm going to have 3 distinct sets here. I'll have one unioned with another, unioned with a third. Now, what's important to note is that we always read these left to right as well. So my orange section begins at negative infinity and stops at B. The next one begins at C and stops at D. And then the next one is from F to infinity. My positive sections were identified with yellow. Okay. And those, once again, start, we've got 2 yellow chunks here, so we'll union those as well. I start at negative infinity to A, and this one is from E to G. I am negative when I am pink. Here we go. I'm negative when I'm pink. Now, here's what's crazy. So you see how this connects all these together, right? But when we get to point C, you'll see that we are not negative because we are 0, right? We are 0 because that is an x-intercept, right? We talked about that. That's a relationship between these points on polynomials, okay? So it's not negative. It stops being negative for just a second. So we have actually 3 unique sections here. Oops. I'm going to union that. There we go. So from A to C, and then it stops being negative for just a second, picks back negative up, and from C to E, and then again from G to infinity. Now, we saw our minimums and maximums, right? Remember, our minimums are where the water pools up. That's why we used blue. And our maximums were little grassy knolls, right? And I have those 2 things. Now, I'm going to label these differently because we're going to assume that these things here, we're going to call these our x values, okay? So what I'm going to say for my maximum is right here at C and F, but I'm interested in the x or the y value. So I'm going to say f of C, which in this case is probably 0, and f of F. I want those values, okay? And then likewise here, this will be f of B and f of D, so the y values. Okay?